Everyone, thanks for joining. My name is Dharmendra Ahuja and I'm a DevOps lead in IBM. So today I'm going to talk about unveiling the power of observability using Up Fluent Bit in AWS EKS environment. So as part of this topic, we are going to talk about the power of observability in our daily life. So as the cloud applications scale across the cluster, gaining visibility into our cloud environment becomes extremely difficult as the application loads scale. And when the application complexity increases because of the scalability, it is getting very difficult to get into the details of the application. So it is so in this session, like we will unveil how to harness the true power of the observability in our AWS EKS environment using a Fluent Bit, which is like a lightweight processor, which is built for modern architecture. And also we will learn how FluentBit can actually efficiently collect, parse, filter, and analyze and route the logs from our containers platform, and like how it routes to how it routes the Kubernetes metadata also, and stream them into destinations like Amazon CloudWatch, S3, or OpenSearch, or any observability backend of our choice. And so we'll break down also the real world use cases in this session and how we deploy FluentBit in the real world scenario. So we'll be covering the demo also as part of this session. So now we'll talk about the observability. What is observability? Observability is like ability to measure the internal state by examining the outputs. So the key pillar of the observability, like a log, matrices, and events, right? And the traces basically. And observability is very important in our modern architecture because EKS, in our today's presentation, we're talking in the context of the EKS cluster, and EKS cluster in AWS runs the complex workload. So observability will help to track the performance, health, and usage patterns across the services, and also also across the nodes and the pods. And also it also provides the visibility into the control plane and also the data plane nodes, data plane events. And also it helps to detect the pod crashes and any node pressure. It will help us detect that. And also it helps to monitor the CPU, memory, disk related matrices also. Observability in EKS, we'll talk about it now. EKS is like a fully managed Kubernetes service by AWS, and it supports native tools for monitoring and logging. So EKS logs everything. Basically, it logs application logs in systems and Kubernetes logs. So we have these kind of logs we have in EKS environment. And we have matrices like CPU, memory, and also we can have custom matrices also. And everything is like traceable. So we have whatever the requests are coming in and going out, like request flows and performance monitoring, like performance tracing, we have everything we can trace. And basically this Fluent Bit help us to trace all the logs and performance matrices. So that is the advantage of having a Fluent Bit as a log processor in AWS EKS environment. So now we will talk about the next Fluent Bit. So what does Fluent Bit mean? So Fluent Bit is like a lightweight log processor, and it's like a forwarder which allows to collect the data and logs from our different sources, and it will enrich them and filter them and send it to the multiple destinations like CloudWatch and like a Kinesis data firehose, S3 bucket, or it can also route it to Amazon OpenSearch service as well. And like it can be used to ship logs to various destinations. But in this presentation, we will be focusing on forwarding the logs to the cloud with in the demo. So now we'll talk about why Fluent Bit is important. So Fluent Bit is like a critical collection layer, and it performs several essential functions. So what Fluent Bit does? Fluent Bit does the collection for us. So when we say collection, so it will capture the logs from different containers and also the endpoints, and it will enrich them. Enrich them means like we can augment the logs, augment the log data with the Kubernetes metadata. We can enrich it, and we can append additional information to the logs, and we can add custom tags. We can add contextual information also to the logs. and also we can transform the logs, right? So we can do structuring, we can do filtering, and we can also mask sensitive information from the logs as well. That is what it does. And the fourth one is routing. So we can direct the logs to appropriate destination based on the content, namespace, and any other attribute which we specify. So we can route it based on that, those attributes. So how the Fluent Bit works, that is the next topic. So Fluent Bit works. So it has a log sources. Logs basically originate from different sources like containers and log files or systemd, right? So these are the log sources from where it will collect the logs. And we have an input plugin. So input plugin basically, these input plugins collect the logs, and then we have a parsers. So parsers are basically the transformers. So they transform the logs into a structured metadata. Basically we use JSON parsing. And then we have filters. So filters will enrich the logs, and it will remove the specific logs from the specific data from the logs. And then we have buffers. So buffers is basically a temporary storage where we are storing the logs in a memory or disk in case of high throughput or network delay. And then we have output plugin. So output plugin is basically to push process logs to an external location like Fetch or Amazon S3 or Kafka or Kinesis Firebase. So now we will talk about the setup. To set up the Fluent Bit, we need to collect the logs from containers. So to do that, we need an IAM role. So we need, which will be attached to our cluster nodes. So we will be using a service account for that to achieve rollback access control. And also we will be in the demo, we'll see how we will set up the Fluent Bit as a daemon set to send the logs to the CloudWatch logs. So we'll be creating the log group, and also we'll be having log string. So we'll be configuring these things as part of the Helm chart. So we'll see that as part of the demo that we'll be using Fluent Helm chart to install the Fluent Bit. So we'll see that. And also we will be using OIDC connector or like OIDC provider to which needs to be created. And also we will need, for IAM role, we need to create the IAM policy. So it is part of the prerequisite. So we will be creating the IAM policy upfront. And also I'll be using VS Code for the demo. So I'm already installing EKS kubectl, and Helm and Git Bash on my machine so that I can make the demo more doable. Just wanted to make sure that once we have prerequisites in place, it will be easier to follow the instructions which I mentioned here. So now we'll come to the demo. So as part of the demo setup, we will also need the logger server. So apart from the prerequisites we discussed, so we need to, once the prerequisite setup is completed, we need to have an application which will be using to route the logs. So to do that, we will be using the logger server like an Nginx server to generate the logs, and then we will forward the service to our local environment, and we will use curl command to do that. So to make the recat request, and also what we will do is we will be watching the logs locally, and also we will be routing those logs to the CloudWatch logs, to the CloudWatch log group. So we will do that in our 3 terminals. So in the terminal 1, we will be using the terminal to forward the logger server traffic locally, and we'll be making a port forwarding to that. And then in the second terminal, we'll be watching the logs locally. And the third terminal, we'll be making the curl request. So then we will be seeing like whatever the logs we are seeing in a local machine, we'll be also forwarding it to the CloudWatch log group. So this is what we're going to see. And then once everything is completed, we will see all the logs going to the CloudWatch log group as mentioned here in the screen. So this is like a sample, but we'll see the similar thing in our demo. So now let's get to the demo. We will start the demo now. So as part of the demo, I'm going to follow the instructions. There are several things we are going to do. So first we are going to create the Kubernetes cluster first. So for creating the Kubernetes cluster, we have a EKS config.yaml file, which we can see here. And as part of this YAML, it is a cluster configuration. So we're going to create a EKS cluster with the name EKS cluster demo, and it is a configuration. So I'm not going to go into the detail of that. So I'm going to create the EKS cluster first, and then so I'm going to run EKSCTL command to create the EKS cluster. So here's the point. So as soon as I execute this command, you can see that it is creating the cluster. So we will look into the CloudFormation stack. I'll just move to that. So it is creating all the dependencies, for example, NAT gateway, subnet routes, and route tables, control plane, etc. It seems like there are several components being created, so it is almost done. So we'll just wait for a couple of more minutes. We can see that the creation of the cluster is completed, and we can see the associated subcomponents as part of the cluster is also completed. So here all the subcomponents you can see, like route tables, internet gateway, and control plane, NAT gateway, etc. All the dependent components have been created now. So we are good with the cluster creation process, which is a prerequisite for the demo. So I did that as an extra step so that I can demonstrate end-to-end demo here. So now we will go to the next step. The next step is we'll update the kube config so that we can access the cluster. So I'll just execute the command for that. Okay, I'll just come here. So we see here, I think there are a few things happening behind the scene. So I think we need to watch first again, maybe 3. Let's give a minute and let me look at what's happening at the code. Yeah. So now it is trying to create the add-ons, that is VPC CNI and kubeproxy. So it is trying to create that. So we may have one more stack coming in. So before we access the cluster using CLI, we need to have this process finished. Then we can continue that. So as we can see, it has created on the CloudFormation stack. So we need to wait for a few more minutes until that is completed. So I'll just show you. We can see that the cluster dependency is also being created. So we've seen like node group is also created now, which we can see on the screen. That stack is also completed, which is a dependency here. So that is good. Now we can see that. So hopefully we should be able to access the cluster now. So I'll just switch to VS Code. VS Code. We can see here, right? It is showing that cluster dependency is being created. So we will go to the VS Code, and now we will just execute the command to access the cluster. And here, so we'll say cubes. We can see that cluster is created, and we are able to access the pods which are already created. So that's a good step. Now the next step would be we will create the namespace Fluent Bit as part of this demo, as we look to deploy all the resources in the Fluent Bit namespace. So we'll go here and execute the one kubectl create namespace Fluent Bit. It seems Fluent Bit namespace is created, so that's great. Now we will go ahead and we will create the OIDC provider now, so that we can associate the service account with the OIDC provider later on. So first we will create the OIDC provider so that we can associate the cluster to that OIDC provider. So I'm going to execute the EKSCTL command. So as part of this process, EKSCTL is a prerequisite. So we need to have the EKSCTL installed on machine. I have already taken care of that. Now I'm going to execute EKSCTL command to associate IAM OIDC provider with the cluster. And this is done. So it has created an IAM OpenID connector provider for the cluster. That's great. I'll go to the next step. So next step is we'll create a IAM service account so that we can have a rollback access control in place. So I'm going to execute the command for that. So in order to do that, we need to have a IAM policy created in place, which is a prerequisite. And I have already taken care of that as part of the prerequisites earlier. So I'm going to just execute the command, and I will walk through the policy later on. So here we can see. So here is I'm creating the IAM service account in the Fluent with the Fluent Bit SA name, and I'm attaching the policy, which is EKS cluster demo policy, which I'll show it to you here how I created it. So I'm just executing this command now, and it will create a stack here in CloudFormation, and I will show you how it looks like. We can see that there's another stack is created. There is a EKS CTL cluster demo IAM service account. So that is a new CloudFormation stack is being created right now, and which is in progress. I will just quickly show you where I have created the IAM policy. So I'll go to IAM and go to IAM and go to the IAM policies. So as part of the policy, so I have created this EKS cluster demo policy, and I'm giving the full access to this CloudWatch logs as part of this demo. So that is what I did, and I created this in advance so that we can attach this policy to the IAM role. So I'll just go back to CloudFormation stack so that I can show the next steps. So we'll go back here, and we can see that IAM service account is also created. So the CloudFormation stack says create complete. So we are good now. So I'll just go back to my VS Code and to execute further commands. Here to the VS Code, and I'm executing next commands now. So now since we have IAM service account created, so I'm going to just describe it and see whether IAM service account is created properly or not. And I want to access it. So I'm going to describe my service account here. So I'm saying yes, it is created. So we can see that. So it is created this. It is associated with this role. So the role is also created as part of this process, and the name is Fluent Bit SA. So that's good. Now as part of the next step. So I just wanted to highlight that I executed kubectl command. So kubectl exe also needs to be installed, similar to EKS CTL as a part of the prerequisites. So we need to take care of that. Now, as part of the next step, I will need to install Helm charts for Fluent Bit to the Helm repo, so that we can, and so once we will add the Helm repo for Fluent Bit, and then we'll update it so that we can access Helm charts for that. So I'm going to execute Helm commands for that. So as part of the prerequisites, Helm also should be installed on the machine. So I'll go here, and I'll just go here, and I'm just adding Helm repo for the Fluent Bit. So that is good. Now I'm going to update the Helm repo. So we'll be going here and updating Helm. So update is completed. That's great. So we go to the next step. Now, since Helm repo is updated, now we'll install the Fluent Bit using Helm commands. So I'm going to go on for that. So here is the Helm command. So it says Helm upgrade install Fluent Bit. So it is installing the Fluent Bit release, and then it is under namespace Fluent Bit. Service account we're not creating because I already took care of that, and we are just giving the service account name, which is already there, and CloudWatch is going to be enabled true, and we are going to create this in US East region, and it is going to check if the log group name is there or not. So it's going to set the log group name if it is not created, and then it is going to we're setting the stream from Fluent demo. So all the CloudWatch logs will be with this stream prefix name, and then we are saying the region should be US East 1. So let's execute this command. So it says Fluent Bit does not exist, so it's installing it now. So we have to wait a few minutes. Great. Now it is executed, so that's great. Now as part of the next step, for the demo purposes, we need to create a demo namespace. So I'm going to create a new namespace demo where we will be installing our app. So we'll just first be able to create the demo namespace. So demo namespace is created. That's good. Now what we need to do is, so since we executed Helm commands earlier, so as part of the Helm command, it has also created the config maps. So we already discussed like what the config map does. So we have Fluent Bit configuration stored there. So we need to update Fluent Bit configuration so that we are just telling Fluent Bit what to output and where it has to go. So I'll just quickly show you what needs to be done. So here I'll just execute this command. Fluent edit cm config map fluent bit hyphen in fluent bit namespace. So now we can see it has created. I'll just quickly show here. Since it is outputted in Notepad, and let's see how we can do it here now. So we can see the Fluent Bit logs. So this is the Fluent Bit configuration, config map configuration here. So this is what we see. So as part of this process, I need to, so this is the configuration looks like. So this is the config map configuration and Fluent Bit. So I'm going to update the outputs because I don't need Elasticsearch here. So I'm going to add outputs for, because we are going to output our logs to CloudWatch. So I'm going to add output condition there. So I'm just adding my output condition there just to make sure. So here we go. So we can see that I have updated the configuration as to output the logs to CloudWatch logs. So it is going to output in USFS2 and this is going to be the log group name, and log string name prefix is going to be from Fluent Bit and auto create to true if it is not created. So that is good. Let's check again how it is looking. So my output is good. That's good. So I'm good. So I just checked it quickly. Now I'm as part of the next step. I'm going to deploy my. So as part of the next step, we will be restarting the daemon set for the Fluent Bit to check on it. First, we need to restart first. So we are restarting because we updated the config map. So it is important to restart it so that it gets the updated configuration. Now, after I restarted the pod, I'm going to check the pods associated with that and making sure if they are created. Sorry, I'm checking. Yes, they're the new pods are created. Now I'm going to check the logs for that just to make sure that it is outputting. So making sure there are no errors. So I think it is good. So we can see that log streaming is creating and everything is looking good. There are no errors. So it is outputting it to the appropriate CloudWatch log group and it is creating a log stream. So that's great. So I'm going to create a stream. And now as part of the next step, I'm going to deploy the Nginx server as a sample application. So I'm going to execute the command for that. And I already have the Nginx server configuration here, which I'm going to show here. That is a logger server. If I show here, so that is a logger server and it is Nginx type, like match levels app Nginx. So I'm going to deploy this so that we can forward the logs and then we can forward the logs. So I'm going to apply this. So that's great. So we have exposed the server service for logger server as well. So that is great. Now as part of the next step, we will open another terminal to do port forwarding in the logs. So I'll be executing the command for that. I'm executing the command here. So here I'm doing a port forwarding for this server to port 84. So this is done. It is forwarding other logs from 8080 to 80. So that's good. Now we'll do the next step. Now we'll open one more terminal to check the logs. So I created another terminal here and I'm executing a command to check the logs. So in this terminal, we'll be checking the logs whenever we make a request. So that is good. Now we'll go to the next step. And as part of the next step, we are going to make a curl request port 8080 and we'll see if it is able to forward the logs. So I'll be executing the command for that. So now I'm executing the command. So for that, I opened another bash terminal and I'm making a request. So here we can see that this is welcome to Nginx. So we are able to hit the endpoint, localhost 8080, and we can see here, and it is forwarding the logs. So that is great. Now we will go to CloudWatch and see if it is forwarding the logs there or not to check on that. So I'll be showing you the CloudWatch logs now. Now we can see that CloudWatch logs here. Here we can see in US West 2, that is the output location we mentioned. So it is creating the log group, EKS application logs. I think that is the log group name we gave. And just created that with that name. And we specified the log stream. So it was from Fluent Bit. And we can see that it is outputting the logs here. So today it is 27th in UTC time. So 27th May. So it is outputting the logs here. And we can see that we see all the logs here coming in. So that is good. So now whenever we are making the curl request, it is outputting the log here. So that is a great success here. As part of the next step, what we can do is we can see these CloudWatch logs in a CloudWatch dashboard. So I'll walk you through that process as well. So here we go to the CloudWatch dashboard, and I have already created CloudWatch dashboard as part of this demo. So EKS logs is a dashboard name. So if I click on it, it is going to show us the logs. We can see, so we are streaming the log for this log rep name, application log. So this is the log rep name we gave, and it is showing the logs, all the logs coming to the CloudWatch. It is just displaying it here so that we can make the meaningful information out of it. So similarly, like it is just one, but we can have multiple filters and multiple log groups we can create, and so that we can output the data accordingly. And we can also customize these logs based on the different metrics type. For example, CPU, memory, disk, like several parameters are there. So we can create the different matrices and we can output to the different log groups, and we can display it accordingly so that we can make the meaningful information out of it. So we can see, for example, like we are at the different point of time, we have a different type of logs, like different and like number of requests hitting. So that is the information we can make out of it as part of this demo. So now this is the end of the demo. Now we'll talk about the real world examples. So let's look at them one by one. So first, now we'll talk real world examples. So let's look at them one by one. So first one we'll talk about is the fintech client. So fintech client needed a centralized logging system to so that the challenge was to there were multiple microservices running in a EKS environment, and the bank needed a log aggregation solution to comply with the financial audits and also audit trails, and so that they can access these logs easily. So the solution was given in terms of Fluent Bit can be deployed as a daemon set on EKS nodes. So, and we will configure the Fluent Bit to tail the container logs and ingest them with the Kubernetes metadata, and then forwarding all the logs to Amazon CloudWatch logs. So this was the solution given, and the result was amazing. So the bank got the centralized logging system, and it got access to all the logs, which helped them to improve troubleshooting, and it increased the efficiency for the bank, and they got the operational visibility as well, and they were getting automated alerts for everything, and it gave them a faster incident response. So that was a success story for the bank. So the second use case is about streaming logs to Amazon OpenSearch company. So there was a SaaS monitoring provider with the customer. So the company needed like a scalable low latency solution to index the logs from their Kubernetes environment, and so that they can basically so that they can query the logs in real time. That was the main challenge they had. So the solution was like they use Fluent Bit as a daemon set to collect the logs, and then they will enrich all the logs with the Kubernetes metadata. And then as part of the streaming, like outputting the logs, they output the logs to Amazon OpenSearch service, and then build the Kibana dashboards on top of it so that they can query these logs in real time. So the output was amazing. They were able to get near real-time log availability, and which improved the monitoring and troubleshooting for them. And also customer gained very good real-time experience and the analytics capabilities, and also the operational overhead was reduced with this process. The third use case is about online gaming platform client. So they wanted to forward the logs to third party service company. So they were using Datadog as a service initially to route the logs from EKS to Datadog, but they wanted to make it more efficient. So and they wanted to find a way so that EKS container logs can be sent to Datadog without impacting the cluster performance. That was the main challenge. So the solution given was like they deployed the Fluent Bit as a with the HTTP plugin, which was configured for Datadog API, and then filters were applied to reduce unnecessary log volume in the production. And also they use Kubernetes metadata to enhance the logs. So the result was they reduce the log ingestion cost through the selective filtering, and then also it helped them to improve the debugging experience. So that was a very good benefit they got. And also they got the seamless integration with the Datadog. So that was a very good success story for them. Now the fourth one is a success story of a healthcare provider. So this is a real world example where they were having the challenge was like for healthcare client they have to maintain HIPAA compliance, which is required for collecting and retaining the logs from the containerized workloads. So that was the a challenge. So the solution was they deployed Fluent Bit as a daemon set to collect the container logs, and also they needed Linux audit logs as well via systemd input plugin. And then logs were forwarded to a dedicated S3 bucket for the long-term retention. And also security team also used like Splunk to ingest from S3 for forensic analysis. So this was the solution given. The benefit of this was like they ensured compliance with regulatory requirements, the HIPAA requirements they were able to comply with them. And also it was a very cost effective and very effective for investigating the incidents also. So that worked really for them. So the fifth one is multi-tenant logging in a company. So they had a multi-tenant Kubernetes cluster. So they had multiple namespaces, and the pods were running in multiple namespaces. So they wanted to ship the logs in an isolated way and making sure they're shipped in a secure manner per tenant. So the solution was FluentBit was deployed as a daemon set with the filters to add the tenant labels based on namespace, and then routing rules were configured to send the logs to separate Fana Loki tenants using the Loki output plugin with the tenant specific URLs. That was done, and then the result was amazing. They were able to get the multi-tenant log isolation without the need for separating the cluster, and it simplified the platform operations with centralized logging system and the centralized logging management for them. So these were the real world examples you wanted to discuss here. And now we'll talk about the references. So I have referred the AWS official documentation to prepare this. And thank you very much for being part of this session. And please let me know if you have any questions. Thank you.